method used to test whether the means of two independent groups are equal or not. The assumptions are, first, two groups independent. Second, the data values are randomly got from two normal distributed populations. When we cannot safely assume the normality, we can perform a non-parametric test that doesn't assume normality. If your sample size is very small, you should also report the non-parametric test, also called Wilcoxon signed rank test. Wilcoxon signed rank test does not assume null distributions. It doesn't deal with parameters, and therefore we call it non-parametric test. Luckily, SAS Studio always gives us an option to test for normality of the data, and output the non-parametric test result along with the t-test result. You can choose which one to report. Here is our example. A clinical trial is conducted to determine the effectiveness of a drug A in preventing premature birth. In the trial, 30 pregnant women are to be studied, 15 assigned to treatment group that will receive drug A, and 15 assigned to a control group that will receive a placebo. Patients are randomly assigned to each group. Data is saved in an Excel datasheet with 3 variables: patient ID, treatment, and the baby weight. Data name is drug A trial. Let's go to SAS OnDemand and open our SAS Studio interface. Every time when you finished the analysis, try to close all the program window so you won't accidentally run a previous program. If for some reason you want to save it, you can save it. And there's a save folder in there. Okay, upload the clinical trial data under the research folder. And right-click, import the data into the SAS system. After you run, you can see the work.import data created. It's under the libraries, my libraries, and work folder. Here's the import data. Now click on the tasks and statistics. Double click on t-test. The analysis window opens. Choose the dataset. And we need to do 2 sample t-tests. The analysis variable is the baby weight, and the group variable is treatment group. And in the option, we keep the 2-tailed t-test, and the alternative hypothesis is test mu1 equal mu2 is correct. And we check the normality, test of the normality. We also check the non-parametric test. In plots, keep the default plots. And I think that's it. We can click on the run and see the results. That's a computer calculate the result for us. In the right side window, we have 3 tabs: code, log, and results. Code is for coding. We can edit it. We will talk about that later. Log window shows some basic procedure information. If there's an error, the message will show in this window as a red letter. The result present the results. The first 2 tables in here is test if the baby weight is normally distributed. From here we can see both groups, the drug group and the placebo group, are all normally cannot reject the normality because the p-value are less than 0.05. Next 2 table is describe the variable, the baby weight, into separate groups. Include observation numbers, mean, standard deviation, ranges. Then it comes to the t-test results. There are 2 p-values. Which one we should report? In our data, they are same, but in most cases they are not. We should look at the equality of variance. If the p-value in this equality of variance table is larger than 0.05, we should report the pooled p-value. Otherwise, report the other one. Next is default plots we requested. The very last are non-parametric test results. Since the data are not skewed, we don't need to report them. Download results into the RTF file and open them in a Word file. Now we can use this data, all the table, all the plot, for your report. Here's how we report. First paragraph describes the data. Second paragraph tells the statistical method and the result. That's for today. See you next time.